Oh lordy. All right, we gotta shake things up a little today. I had thought about doing a web work, and then I thought, let's take a break. Not because of UCA, but maybe because of USCA of days of old, days of yore. So let's see here. I got another, you know those sheets you love to reference? Here's another one.
Thank you.
Oh, you're so welcome.
Is this all you're making? You handing us a piece of paper?
I'm handing you a piece of paper. There's things on the paper, but yes, that is true.
You don't ever hand us paper.
I know. That's what I said. I'm shaking stuff up today. Do you know if Jose is coming? You don't know.
I thought he was.
And then Atman, who knows?
There he is.
There he is. Fantastic. Hello. That's for you right there.
Was this
That's
week,
for
did you only do this because you knew we weren't, or?
Where is this? I also wanted to have a nice summary of it.
That's so thoughtful.
That's the way I roll.
So thoughtful. This is, I don't know.
It's gonna be great. We'll make sense of it in just a second, yeah. And I was thinking of a different way to maybe express how to do some of this stuff. So then we're going to do an in-class sheet together after I talk about how to do some stuff, and that'll be the assignment for this. And then on Friday we'll start something new. Sound good?
Very neat.
Yeah, I think it's cool. So I'm gonna hold on to that, so you just wait. Just wait a second. All right, friends, let's get rolling. We're doing volumes. I don't think there's anything to have questions about, right? There was no, you don't have an assignment floating about.
There's one due this week.
Is there?
Yeah, let's look at that. There's a web work.
I'm not sure on the facts on that. Let's see.
Is it the area one that I
Oh.
just made do super?
But 18.
I'll be damned.
Wait, I thought we just did this one.
Yeah, that's okay.
Wait, there's two homeworks on improper integrals. And both
No,
of them are
ignore,
full.
there's only one that's available, right?
There's one that's available, but the one that closed was on, that was on Sunday, and now there's another one open.
Let's see.
So this one is just called improper integrals, we
Yeah.
had that one due on Sunday, and that closed. And
Yeah.
then this one is open, which I didn't know until right now, and it closes.
Can you go in there really quick?
Sure, no problem. Let's see, we have improper integrals, this is problem one.
Oh. Yeah, I don't think there's anything wrong with leaving. Can you just go through them real quick
Yeah,
for
no
me?
problem.
Yeah, oh, these are easy. Yeah. No, I don't want that one in there. That's terrible.
You don't want this one?
Yeah, I'm a little, no, I don't want that one in there. That sucks. That problem really does suck.
It's the next one.
Yeah, okay, can I see 5?
Yeah.
That's a good one. Oh, I remember this now. At least I remember pulling it together, but I'm taking one of the problems out. Those are pretty easy except for 3. Can we go back to 3?
Yeah, let's look at it.
Yeah, we're not doing that.
This is like the exact
We're not
same
doing
thing
that.
as the other homework.
Yeah, is it a lot like that
It's
one?
pretty much identical, like we solved this basically exactly.
Okay, then, yeah, we did, so,
Yeah.
okay, we're not gonna do that one. So don't worry about the one that says improper integrals.
Maybe I should
Remember?
just show you the one that you did give us.
Yeah.
This is the one that we did have.
Oh, okay, yeah, that's great.
It's
Yeah, that
basically
was
the
kind of what I was
same exact
thinking, yeah.
stuff.
I didn't want a
This
whole lot
one.
about perfect.
Yeah.
So the one that says homework 4, improper integrals, we're not gonna do. Do not do it. And I'm not gonna do it anyway, but
So this one, we don't have to do it.
do not do it. Yeah, so let's put that on the record. Homework 4, has anybody done it already? I like that laugh, that tells me everything I need to know. So, that's what I was saying, so don't worry about it, there isn't, you're probably good. Let's just make this official, homework for improper integrals, that's bogus. Do not do. Don't do that, please. Should be easy, because nobody's done anything on it, so don't do anything on it, that's cake.
Yeah, this is.
That is cake. Let's get some volume stuff done, because I kind of want to rock this out. And I'm setting this up to be the most general thing we can possibly imagine. So we've got a function y equals f of x, a function y equals g of x. And those run, and we've got maybe x equals b and x equals a here. We're interested in taking that region and spinning it around, all sorts of different things. And last week, we talked about first spinning it around the y-axis. Yeah, just like that, spinning it around. And remember how we did that? We took an arbitrary x slice. It's going to be really important that you think in terms of pictures here. So I take this x slice, let's see, so that's g of x right there. And I'm going to envision what that traces out as I spin around whatever axis I've been told to spin around. So now if I was told you to spin this around the x-axis, what is the shape of this rectangle after it's spun? It's a rectangle now, but yeah.
Like coming down like this.
What does it look like? Yeah, just a disc, yeah, kind of, but a washer. Right? So a disc with a hole in the center. Same, yeah. Yeah.
Right, so if you were to map every point of it,
Oh.
not just like what is the final and the initial position.
Agreed.
Because the initial position
Yes,
looks
yes,
exactly like that.
100%. So what is the locus of points traced out by that shape as it moves through space? And that turns into a washer, right?
It's like hollow.
Like that, and then there's my axis, kind of like that. Does that make sense?
Yep.
That looks like
Alright.
iron too.
That's so cool, I don't know how you do that.
Oh, it's magic, man. Here's how you do it.
Looks like.
Make an oval.
Mixing it up.
Make another oval, but first extend the depth, and then just trace, actually just mimic that, and then make another little oval in the center, and put a little phony dude in like that.
Cool.
It's fun, I like drawing them, so, yeah, they're pretty groovy. So these are washers, and this whole washers and discs, so the same disc, there's nothing wrong with that, it's just a washer is a disc with a center missing. But the routine here is going to be the same. And I want to actually just open up today with a more general proposal and talking about a more general problem. And I think we kind of ended there last time. So if I take the line y equals L, and instead of spinning around the x-axis, I spin around y equals L. What shape will I get?
A bigger one.
A bigger one, right? So we just need to work as though all this stuff was just given to us, and this is the x-axis down here. We just have to account for it. So one thing to notice is that this distance right here is actually L. Right? That distance right there is L. The distance from the axis of rotation to the x-axis. So, how do we find the volume of a disk like this? Well, first off, we're just going to say dx is the thickness, and the outer radius, let's put it like that. So the outer radius is going to be what? If I'm taking this disk here, at this slice x, can somebody tell us what is that outer radius?
Of x minus g of x.
That's the thickness here. So right, that's the width of the disk. I agree with that.
Okay.
But what is the distance from the outer edge to the center? And it's not that.
Are we still doing it from y equals L, that rotation?
Yes.
Over L?
Yes.
Okay.
So rotating around that new horizontal axis. Y equals L.
X plus L.
Yes, and we just, yeah, so you're thinking absolutely right, but this L here is actually, it looks like a negative number, just the way I've got it, so let's just be a little bit careful. So realize this L is negative, but we'll just subtract it off to get that distance. In other words, we're gonna take the top, the outer edge. Look at how I'm thinking about this now. I'm thinking about the outer radius versus the inner radius. And if you think in terms of outer and inner, you don't need the formulas on that sheet. You just need the basic idea. So here, the outer radius of a slice at x is going to be the top f of x minus whatever this L coordinate is down here. If the L turns out to be negative, like it looks in the picture, then it will be addition. But if the L was positive and above the x-axis, that would still give me the distance. So for example, if that was L right there, it's still gonna work out the same way. It's gonna be that coordinate minus that coordinate. And I get the same answer. The key thing is, outer radius is right now gonna be this curve. If I took an axis that was above here, so let's say I did a y equals L, but it was above here, now who's the outer? It's gonna be the G, right? So you gotta do the picturing in your head. Make the slice, imagine it's rotating around what you want. If the axis was up here, the outer radius would be this coordinate where I'm rotating around minus the new outer edge, the height at g of x. So in other words, this would be my outer radius at that point. I just have to figure that distance. So, right now, the way this picture was drawn, so we're gonna make some assumptions. Here, L is under the region. And then my outer radius would be top minus bottom. And it's always gonna be top minus bottom, but what we're doing now is practicing picturing. What is my inner radius here? In other words, this distance here.
Would it be g of x minus L?
Beautiful. Top minus bottom. Yep. See? That's my inner radius. So what I'm going to do is use this volume formula that says, if I have, this is for discs and washers. If I have discs and washers, this formula is going to work. It's going to be pi integral from A to B. This is the range of slices from A to B. Outer radius, let's write it like this. Outer radius, depending on x, squared minus inner radius squared. dx. And if you think outer radius minus inner radius, you don't need the sheet, but the sheet's there. Yes, sir?
Could you just put that as like brackets, outer radius minus inner radius to the second power?
Let's check. Like this, of x. I'm gonna abbreviate it because I don't want to write that. Like this?
Mm-hmm.
Are these the same thing? Did you say no? I thought you said no right after suggesting
He
it.
did not say no.
Are these the same thing? Is a squared minus b squared the same as a minus b
So sad.
squared? What do we call this? Freshman's dream. Remember, we talked about that. We cannot bring exponents into sum. You're not alone. You're just the brave one to say it, because everybody else is kind of like, oh, I'm not sure if that's true or not. That is a lie.
Okay.
Lie. Falsehood. And let me prove it to you. 2 squared, I better be careful here. I might do something that doesn't work out. Minus 1 squared. And let's compare that to 2 minus 1 squared. So this is 1 and this is 3.
3 equals 1.
Just
Yeah, nice.
Lie. Lies. So be careful. So no, we will not take this formula and convert it like that. Just make sure to keep those guys separate. You'll be safe.
Okay.
So let's take a look here. Let's do a couple examples that aren't on the sheet of problems we're gonna knock out today. So example, I'm gonna take y equals sine of x. And I'm gonna do x is between 0 and pi. So I'm gonna get my good old first lump like that.
Hi, sir.
Howdy.
Sorry for being late.
It's okay. So I'm gonna get my first lump of sine, just like that. Of course, that's 1 right there. Let's set up the volume integral. So rotate about. First one, I'm gonna do a nice low-hanging fruit. Let's do it around y equals -1. So there's my picture. You definitely want to have this picture, and it might not be as important here, but in a minute, we're gonna rotate around a vertical axis, and you're gonna want that x marked off. Rotate around this. So what's my outer radius? And so this height here is a 1, right? The height there, that's x sine of x. What is the outer radius at the coordinate x?
X minus L.
Yep, cool. Give me those for this precise problem. Agreed.
Sine of x minus L.
Beautiful. And what is L?
1.
-1.
Oh, right.
Does that make sense? And think about it, you're actually adding 1. This is what Kellen was thinking in his head when he gave that first answer. He was adding that distance. But if you just do the subtraction, you're gonna be safe. So the outer radius is sine of x plus 1. What's my inner radius? Yeah, 0 minus -1. Yeah, does that make sense? Yeah, exactly. So it's gonna be 0, which is just, that's AKA the x-axis. Right? Minus -1 equals 1. Or you can just realize it's always 1, because it's a cylinder that we're gonna be
I have a
removing.
question.
Yes, sir?
I understand in this problem why L is -1, and I feel like this is a really good example because we're using a sine graph, but I don't see how that could replicate well. Like, is it an arbitrary value? And we're able
The L?
Yeah,
Oh yeah, I just made that up.
okay.
So
I
let's,
understand why it's -1 here, like, that makes a lot of sense for this type of graph.
but we could make it, what if I just made it this?
Well, I don't know, that's what I'm asking.
Well, let's talk. What if I made it that, y equals -10? Then it's gonna be sine of x minus -10.
Yeah.
So it would be sine of x plus 10. In other words,
Right.
sine of x is that height plus that extra 10 right there.
So what is the, I understand, like, the math part is fine, that's no
Okay.
problem. But like the value that you choose to be L,
No, you won't choose that. You'll be given that.
oh, it is a given thing.
It is a given
Oh,
thing.
okay,
Yeah,
okay,
no
okay,
wonder
okay.
that's
That-
kind of like,
okay,
how does he do that?
That changes everything.
Yeah, I'll always give you the
Okay,
access.
okay, sounds good.
Cool. So that makes it even easier, right?
Yes, it does.
Not bad. So our volume of this shape, which is going to look like, it's gonna be like this parabolic tire with a flat, it's almost gonna look like a bike tire, kind of, right? It's gonna look like this little half of a tire, and then these cross sections look like that sine lump right there. So you just kinda, that's super shitty. I'm embarrassed by that drawing. But I integrate across the range of slices.
So,
Yes, go ahead.
so you're saying that, what is that, that's, okay, I see, so you're getting the slice from x, sine of x. That's the disk,
Yes.
then those small, like, parts that you're making right there, that's from that curve that we have on the sine graph, is that?
When you say those small parts, that's a little too vague for me. What do
Like
you
the
mean?
slices on the disc?
Oh, the things. you-
Yes. So
That's-
ask your question now that I understand what you're saying.
So that slice on the disc, Is that made from the curve? In the
Yes.
sign graph?
Mhm.
Okay.
Gotcha. Yeah. And those slices are gonna change depending on what the value of sine is. Up to right here, when we're actually at this endpoint, there's no thickness there at all in the solid that's rotating, so it's just gonna be 0 minus -1. And you're, at this point, you're just pulling out a pure cylinder. So if you think about, yeah, I don't wanna say anymore, I think it might get confusing. I might even confuse myself.
I'm really confused. So
Okay.
I think I'm just having a hard time visualizing it maybe, so is the slice, like are you drawing where, so that value of X that we had is like basically smack in the middle of that? Is that what you're saying, it changes based on where that is? In the
Yeah,
value of sine?
yeah, the slice, the X slice is
Yeah,
like
right.
sitting in here and it's gonna change height as you move across.
Across that hump?
Yeah.
Okay, I got that.
Yeah, so like out front, there's like almost no disc here.
You're right.
And then here, we're gonna get one that's very thin,
Uh-huh.
and then they get thicker, and then they get thinner.
As the hump goes?
Yeah.
Okay, yeah.
Alright, let's set up one. Try this. Take the same shape, 0 to pi, rotate, and come up with the volume integral about y equals, how about we just do positive 10? So that was -1 before, let's do y equals 10. Now spin this same region around that, and it's gonna be a tire that's flat on the outside with this weird, like, kind of parabolic innards.
Is that supposed to be 10 or?
That is 10, should be 10, thank you. And don't do the integral, just set it up. You think outer and inner, and you're gonna be rocking it.
And we're trying to put what over that? The hump?
This region that's shaded,
Okay.
kind of. No,
That
shaded.
shaded the whole thing, you mean?
We're trying to get that.
That first lump,
Alright,
yeah.
I'm done. So done.
Oh, just,
That wasn't, sorry, that wasn't like a giving up, I'm done, I was like, I'm done, I'm cooked.
you're cooking.
Well, that's the,
That's a little.
That's not giving up, that's
a
making an
little-
observation.
It's a little
That's different.
dramatic.
Alright, well, you know.
It's a little too early to be that dramatic. Let's save that for at least
On the day.
3 o'clock.
3 o'clock. It's true, it's only like what?
What? You-
26?
You know how you could feel better about it?
It's not.
I think you can do it. I kind of think you can. Oh.
Talking to you,
Sorry.
you're okay?
Oh, yeah. Just laughing.
That was a joke. That's not my
You
sorry.
get
You
that?
don't have to be embarrassed, it's okay.
Oh, I'm not. It takes a lot to embarrass me.
Is that true?
Yeah. If you ever want to have a competition someday,
Oh, it doesn't sound like I do.
I don't think you want to do it. Let's see, Atman, did you get one of these? Okay, cool, yeah. Yeah, when I turned 50, I told my best friend, I was like, you know what, I think I don't give a shit anymore, and he said, you gave a shit about stuff. I did, so look out. And again, so your outer radius is this distance, just, and your inner radius will be for your X slice. There, and it will change, depending. So always think outer radius minus inner, and if you do top minus bottom, you'll always keep things positive. Here, this won't matter because you're squaring stuff, but it's kind of nice to just keep it straight in your head.
I have a question.
Yes, sir.
Is the outer, this is a basic question. Is
Yes.
the outer radius always from the x-axis or to the new?
It's from the bottom of the shape, which is right now the x-axis,
Oh,
yeah.
okay, okay,
Yeah.
the bottom of the shape would be
Yes.
a better
Well,
definition though.
But it's not always the bottom of the shape, it depends on who's on the outside as I rotate, right? So here, the bottom is outside. If I rotate about here, take this and rotate it around that line, this is the outer side, this is the outside, it's flat.
But if I'm trying to rotate the x-axis, the top would be the outer.
Depending on if you rotated something above it or below it, you're gonna have a different outside of your tire.
This is the outer, right?
There you go.
Flipping it over,
Uh-huh.
it's still the outer. This is connected to the
Yeah,
x-axis.
uh-huh.
But when you're trying to
Where did I
rotate
put
this,
it? Oh, here it was.
this becomes the in, this becomes the outer.
Right, cause you flipped it, cause it stays attached, right, so this
Yeah.
flips up.
What's my outer radius for any x slice?
X times 10.
It's this distance. It's what?
Nothing.
That is some mumbling, that's some college level mumbling. What's the outer radius?
10 minus 0.
10 minus 0, yeah. It's fixed, right? The outer radius is always this distance all the way across.
So wait, in this case, L is, why is L 0?
L isn't 0. L is 10.
Yeah, I thought it was minus 10 also. Okay,
It's always top minus bottom, and we're always looking for outer squared minus inner squared. You have to picture this. If you're not trying to picture this, it's never gonna work out.
So,
Yeah.
so you're subtracting L. So you're
Stop
doing L.
thinking about L. Just think about what am I doing. Stop thinking about formulas. That's what's
Okay.
screwing you up.
Okay.
I'm rotating around this line. Do you agree this is the outside down here?
Yeah.
Okay. How far is it from the axis of rotation to the outside?
10.
Always, right?
Yeah.
Because this doesn't change.
Right.
And that's all we're saying here, that the outer squared is just always 10 for this particular situation. Let's talk. Let's keep going. Let's do the inner.
But, okay, so your 0 in this case is,
Yeah, the zero is the x-axis. If this had been defined by some weird function, then it would have been 10 minus whatever that function is there. And we'll do one like that in a minute. This is supposed to be the easy one here. So I think it's screwing you up.
it's just, yeah, I'm like thinking with the
So
formula.
help me with this. Stop thinking with the formula. How far is that distance for a particular x slice?
9.
In the center, yes, but for an arbitrary x, you're doing it x equals pi over 2, where this is precisely 1 unit high. How high is this for an arbitrary x? It's sine of x, that's the definition of the function. The function gives me the coordinate of the y, so this distance right here for any x is literally sine of x units high.
Oh, that's right, that's right.
So tell me now, Jose, for this x slice, how long is this segment here? If you know that this is sine of x units long.
Would it be 10 minus sin of x?
Yeah, it would. Beautiful.
Okay.
Yeah?
Yeah.
Okay.
I see it.
Awesome. Yeah, we good? Let's do another one. Let's do this shape that is between, let's do y equals x squared and y equals, I don't want to, that sounds like it could be not cool. So let's do y equals negative x, that's lovely. Cool, and then we'll cut this off like this. And we're gonna run from 0 to 2 on the x-axis. So this is my region. Again, this is y equals negative x here, and this is y equals x squared here. We don't know who's outside or inside yet, because I haven't picked an axis to spin around. Is that, we're all good?
I agree.
Yeah, you agree, awesome. So let's rotate around y equals, let's see, what is the lowest y coordinate on this thing so that I can get below it? What is the tip, the y coordinate of the tip? -2, yeah, because it's y equals negative x. So that's -2, so as long as I pick anything below -2, I'm good to go. Let's set up the volume integral. Draw your arbitrary x slice, like that. Which curve is the outer curve now? Which of the two bounding curves up here is outer? Top, right? Yeah. Y equals x squared. But that's not your outer radius though, right? Because we're spinning around down here. So you need to figure out what is that distance. That's your outer radius. Your inner radius is that distance there. So just pi outer squared minus inner squared.
Can you do that thing you just did again?
You're using a slice.
Like I'm just choosing, yeah.
So I'm sorry, what is
So
it?
you're
asking?
choosing the slice?
Yeah, so I'm choosing an arbitrary slice in the region that I'm drawing, and I just draw it on there. You could draw it anywhere, you can't go wrong with it.
Okay.
Or you just keep
And-
it as x.
But
Yeah.
and you're rotating like
Mm-hmm.
X, Y?
Yeah.
So, okay.
So Alexander, let's have a chat. How long is that distance right there?
X squared minus 3? No, it's,
Yeah.
yeah, no, that's correct.
X squared
Plus
minus-
-3.
Yeah, hell yeah.
Yeah.
So that, yeah, brilliant. There you go, that's your outer.
Uh-huh.
So let's start getting some
Yeah,
shit.
and equal A and B are like the values. Yeah. You're right.
And now, yeah, sound good?
And
Cool, what's my inner radius? This distance right here.
Negative X minus -3.
Yep. So plus 3?
It's squared.
Yeah, it's squared. Yeah, there you go. Seems like you got it. Does this make sense?
Yeah, it does.
Have fun?
Yep.
You cool? Right, gentlemen? Good? Okay. I had a sense. Just wasn't sure. All right. Now do it around y equals, again, highest point here is what? What's the highest point? 2. The x coordinate's 2. 4. Because it's squared, right? It's the y squared. Yeah. So as long as I pick, so about now, let's do y equals 100. Luckily, we don't have to do anything but set it up. So this is, I can make up whatever, you make up whatever crazy shit you want there.
For the same problem, or even?
Yep, same region, rotate around this now.
Placing -3 is 100. Switching.
Yeah, switching. Yeah, outer and inner flop.
Because they flip, right?
Uh-huh. say, yes, thank you, sir, yes, it is 100, thanks.
You were so quick. You ran away from yourself.
I did, yeah. Oh, I've been running away from myself my whole life.
Wait, no, that's not. Alright,
What's up?
nothing.
Okay. You wanna do this one with me, Jose?
Negative X.
Oh, damn, okay, hold on. Alright, so that's cool. So, yeah, you're thinking right, this is our outer radius, right?
Yeah,
Let's do top minus bottom.
okay,
10, or 100.
Okay.
Minus what?
minus X. Oh, sorry, X squared.
That's the inner radius.
So,
This is
minus,
my outer radius.
yeah,
It's hard to
minus,
see it.
minus negative X.
There you go. Yeah.
Oh,
You said minus x the first.
gotcha, okay,
So like that, and I do the double, I do a parenthesis, because it turns into a plus then.
Yeah.
Right? Cool, and then what is my inner radius gonna be?
100, minus X squared.
Solid, beautiful, yes. Yeah?
What did you put here?
Okay. You now can pretty much do any cylinder or disc thing. And for everything we're doing here, we're assuming that all our functions look like this or like this. They're all functions of x. We won't talk about the other for a little bit. If I have a function of y, let's not talk about that. But let's move on to what happens if I spin around a vertical axis. We have a different formula because things look different. So let's say I've got a pen that works. Let's say that because I don't. Try blue, shake it up. Come on, blue. Come on, blue. Yeah. All right, so now we're going to take kind of a similar region. Top is bounded by y equals f of x, bottom is bounded by y equals g of x, and that runs from A to B on the x-axis. But instead of spinning horizontally, I'm going to spin vertically now. So we're going to spin around the line, and we're going to just set this up in general. Let's spin around x equals m. So now I'm spinning around vertical. And so it's because we're in calculus, we cut the shape up into little rectangles and we think from those. So the first thing I'll do is pick an arbitrary rectangle, I'll mark an X in the interval and draw my element in the shape, in the region that I'm going to spin. What will this look like when I spin this around? So what will that little slice look like?
It would look like a washer, but like on its side.
Yeah.
Two-dimensional.
Yeah, like a can, like the outside of a soup can or something, right? Does that make sense?
Circle.
Cylinder, like a cylinder, right? Do you see that?
Yeah.
Does everybody see that? Yeah? So if I spin that guy around there, what I get is something that looks like this. So you draw yourself a little, right? So a can, and it's got a thickness to it. That thickness would be delta x, but we'll just say, dx is the thickness of that can right there. And then I've got some radius here, r, and I've got a height. And this, let's do the height on the outside, it's easier to mark off. So I have a height h of the can. Now we gotta figure out what the volume is of that thing. And the way to do this is to make a cut in it. So I'm gonna cut it along one side. What happens when you take a cylinder, you cut and then you flatten it out? What shape do you get?
That one.
Just in general, don't think
A
about
rectangle.
Yes, a rectangle, that's what I'm thinking of, yes. If you took, here, we got it right here. Yeah. Take my can, cut it, flatten it.
Oh, flatten it though, so we're not looking
Flatten
at it like.
Yeah, so I'm taking this thing I'm making a cut, and then I'm gonna think about what it looks like flat. So I'm gonna cut that thing, and then I'm gonna lay it out, and it's gonna be a rectangle, like you said, Alexander.
No, I got that. I was,
What's up? Is everything okay?
well, not really.
No, what's wrong?
You told me to flatten it. But
I
then-
did.
I think it's
Not like, it's not compressing, you're not compressing it.
You mean like, so it
I
has
thought
to
you
go?
were doing like 3 steps, like opening it and then flattening it. But like if you open it, it is flat.
Yeah.
That's correct, right?
It's just not doing the cake.
But
Yeah,
it's,
right.
but it's
But if you went
not.
like this, you like turned it down. Okay, but that's not how we're looking at it though.
Yeah.
We're looking
Okay,
at it like
all
that.
right. Is
Yeah.
that flat?
No.
But and it's open.
Yeah.
So I'm just saying, open it and flatten
Okay,
it.
but no. But okay, when you did it, you were like,
Yes, sir.
we have a pen
Yeah.
and we're gonna open it and then flatten it.
Oh,
Which is
okay.
like another
I said two.
rotation.
Gotcha.
Yeah,
I
and that's
understand.
where I was-
Apologies.
got it,
That makes sense.
I think I got it.
That's my bad.
Okay.
I'll take that one.
Okay.
I'm gonna carry that.
Okay.
All right. How do we find the volume of that mofo?
Length times width times height.
Well, length times width. It's right. It's just a rectangular solid. Length times width times height. What is the height?
Height is n.
This height here, the thickness. It's the thickness of that shell, right?
D.
You're thinking of this. So this will be h here.
Right.
That's the height. How thick is it?
Is a radius?
DX.
dx.
Dx. We'll get to the radius in a second. Yeah. How long is it?
Orange word?
Nope. How'd you get that? I'm curious. That's interesting.
No, I was thinking about, never mind.
What do you mean that's interesting? Why is that interesting?
Because I wanted to know his thought process.
Okay.
It would helps me understand
Is
the
it
world.
the
Just look at this from the top.
I'll just try.
Here's the top view.
Yeah.
How long is that around?
R squared. Pi r squared. 2 pi r.
there it is.
2 pi r is this. Oh my God! Look what you're doing.
Oh no, I'm
sorry. You're-
I'm sorry, Kevin.
He's being compressed, just like this thing.
Well, hey Kevin, you could have said it too, alright? We're over here dying.
Kevin's digging a hole out so he can escape. All right, so the circumference is 2 pi, well, big R, right? So that is this distance, 2 pi r. Does this sound reasonable?
I mean, you're putting, no, but.
Wait, what? What do you mean no? Come on, let's talk. Why not? Don't say no and tell me not why.
It's not that, I probably shouldn't have made that comment, I apologize.
So it is clear?
Well, it is, yeah. You're putting circle, I just don't like that we're looking at a rectangle and putting circle language on it. But it's cool.
I can't,
I know,
those are
it's
your
all good.
emotions,
It's
I
all-
can't,
it's all good.
yeah. I can't do everything, I can't handle all of it.
Try unflattening it and folding it back into a cylinder.
There you go.
Unflattening it and folding it back into a cylinder, no. I'll stick with this black.
God damn it, Kevin, we can't do that. All right, what is the volume of that sheet, given the measure, oh, I'm sorry, you said.
So
Yes, sir.
in this case is, wait, what was it gonna ask? Is dx the measure of f of x? Or
No,
the-
dx is the thickness of this little thing here.
Oh, okay,
It's a slice.
okay.
Yeah, and then when I spin it, it's the thickness of that shell that I produce, or that can that I produce.
Okay,
Does that make sense?
yeah,
Sure, you good with that? Okay.
I think so. I've just been looking at it like you flip that whole thing instead of a slice, so that's why.
Oh, that would be very confusing, yeah. Everything in here, when we do it, we're gonna break it down into simple elements being spun.
Okay, so it'd be like the distance of the slice, like on the x-axis is 8, or dx, sorry.
Yes, so it's just this distance, right?
How are we looking at it?
Everything's about that shaded
It's
slice.
just the slice.
Yeah.
That's why I'm like,
Is this help?
yeah, it does.
Is this-
I didn't even know. I was.
I'm glad we had that conversation. No wonder you were feeling emotional about it. Emotional. Alright. What's the fucking volume?
It's 2 pi r times h times dx.
Yes. Yay. Okay.
Nice.
Now we gotta figure out what are these various things. So what is h? What is the height at slice x? What is h of x?
F of x minus g of x.
F of x minus g of x. Good news, that'll always be same way here. Top minus bottom, all good. So this guy here is equal to f of x minus g of x. And I saw a lot of nods, and that's probably the first time today, so that's very encouraging. So this is going to be f of x minus g of x. Yeah? And then what, and so now here comes the super tricky part. What is my radius? It's this distance here. What is that distance? And it doesn't involve f or g.
X minus n.
Yeah, but do right minus left to do bigger minus lesser. Yeah, it's this distance right here, right? That
I
distance.
guess that's not necessarily n.
And it's not necessarily
It could
m.
be like,
Yeah, so it's just gonna be m, the coordinate for
X,
the rotation axis, minus the current x slice.
So if you called it c, you'd be like x minus, or c minus x?
Yeah.
Yeah, okay.
Yeah, exactly. So we had 2 pi here, and then here we had, what was it, Lm minus x. Now look at what we're assuming here. We're assuming that the m, the x equals m, is right of the region. So that m is actually bigger than any x coordinate in the region. And I just want this to be a positive number. That's the main thing. We'll talk about this in a minute, if the m was on the other side. But what, just really quick, what if it had been, what if the m was like over here? Yeah, what would I take minus
X
my
minus n,
x minus m?
or
Yeah.
whatever you call it.
Exactly, yeah.
The bigger one.
Yes, the bigger one minus the less. Yeah, right minus left, top minus bottom. We'll just keep those conventions and we can't get in trouble. If you do one of these and your answer turned out negative, you probably subtracted wrong, in the wrong direction. So we got this, look. And now we're just gonna sum those all up because this was just one little element. So when I come through here and I add these all up, so we're gonna have sum I equals 1 to n. I have n rectangles that I cut that region into, and I'm gonna have a 2 pi. I'm gonna have m minus x, and then I'm gonna have f of x minus g of x. And I'm gonna add some little subscripts in here, because these are actually particular x's that we have in there. And this dx, it's gonna become dx, but currently it's probably a delta x until we go to the integral. It's dx and delta x, same thing, just this guy here. Should have called it that from the beginning. Same thinking, all good. Delta x here. Now I'm gonna add those all up, and then what am I gonna do? Here's the approximate volume, if I add these sums up. But what are we gonna do with n? What am I gonna do? Are we good with like 5 rectangles in here?
No.
You're like, yes. We're not good with it. How many
So we have to
rectangles?
integrate it to like infinity.
We want infinitely many rectangles in here. So we take the limit as n goes to infinity of that sum.
Not the integral.
That's a Riemann sum. We're taking n as it goes to infinity. What does this turn into?
This is massive, massive development right now.
It is. I'm gonna pull the 2 pi out in front because that's just a constant. What does the sum sign turn into when we go to the limit?
Integral.
Integral. Beautiful. From where to where?
From 0 to infinity. No. From
What's
A-
the x
A
slice
to-
range?
A to B.
And then I've got m minus the current x coordinate times f of x minus g of x, that's the height of the slice, times dx, that's the thickness of the slice, and there's our volume formula. Not bad, right? This is kind of cool. It's kind of cool, just the way this thinking, the thing that we're here to think about is how to think in calculus, right? How physicists would break this problem down and do it. So let's do an example. Actually, let's put a little note here that this formula is if m is right, x equals m is right of the region. But if it's left of the region, I want this to be a positive, so we'll do x minus m. So change this to x minus m.
Oh, like the it's on the other side.
Yeah, exactly. If x equals m is left of the region. Yeah. So, yes, sir.
This is gonna sound a little dumb, but I keep thinking that, like in this instance, that b over a, in this case, would be f of x over g of x. Because, you know how like when you did the rotation over the x-axis, you did like a certain point on the x-axis?
Yeah.
But if you rotate it, I feel like I don't know, in my mind, I'm thinking it's like an f of x minus, or f of x over.
Divided by? That's what you're thinking of?
No, like
Oh,
that's the
okay.
top limit and the bottom limit.
Oh. You could probably, you're kind of working with like inverse functions and stuff in your brain, I think is what's going on there. You're thinking of a much more complicated problem.
Okay.
Yeah. Well, maybe we can sit down. I don't even want to talk about it
Okay.
up here
Yeah,
and
that's
get
okay.
everybody confused, but I would love to talk to you about that. Let's do an example. Let's take our good old y equals x squared and y equals negative x. I like this one. We're going to take this region R, and I want you to please spin it around. Yeah, let's see. What is this point here? That was 2. So spin it around y equals 4, and set up the integral for that region around y equals 4, and then you can have fun trying to think about what that might look like. And it's kind of gonna look like that, but be hollow. It's kind of weird, sharp wash here. This should say x equals 4, excuse me, x equals 4. Because it's a vertical.
It's going around that?
Mm-hmm.
Okay.
Yeah, spinning around, yes, this guy right here. And I'm gonna write the formula out in kind of a heuristic way so that it's easier to think about it. So this is all best done with thought, once you know the plan. Really, that's just the formula. Find the height at an x slice, find the radius at an x slice, multiply them together. That's this formula right here. When I say height, I mean of the region of a slice. This is radius of a slice. Just set it up, don't work it through. I'm trying to think about what you were saying, Yuski. I'm just trying to think about it again.
Is it? I don't know.
Do you wanna do this one with me? Make sure you're not thinking that other way.
Okay,
Yeah, let's do it, let's do it. 2 pi in a range of slices, what's my height gonna be?
The height, x squared minus negative x.
Beautiful, so x squared plus x, yep, nice. Everybody see that? That's your height? X squared minus negative x turns into x squared plus x, beautiful. So that's my height, and then what's my radius gonna be? So it helps to draw, for this, I recommend drawing in that little slice that has x coordinate x. And then you can see how it relates to the axis of rotation.
Okay, so it's just, is it gonna be x minus 4? No, 4 minus.
There you go, you got it, because the x is gonna be less than the 4, and we want that to be, yep, that's it.
Okay.
So now, set up the integral, if I rotate it around x equals -1. So this is about x equals 4. Please do it now about x equals -1. And I'll leave it to you to get all that stuff set up. And then we'll just start working on our sheet together. We got a little bit of time. What is going on over there? What's wrong?
Yeah, I got it.
Okay.
Yeah, I got caught off guard. I got English reading response back with one of the lowest grades I've ever seen.
Oh no, so your brain's a little.
It just like, it just shocked me. It's not a big deal, it's like 60.5% of the grade, but it just like shocked me.
It's just,
I was like, wow.
it's not cool.
Yeah.
Yeah, is that why you left?
No, I
you
just saw
found it
this
when you
just
came back,
now, that's
okay.
why I was like, what the heck? I didn't mean to like distract anyone, I'm sorry.
It's okay, that's my bad, that's what I do,
Distract people?
Yeah. at least right now.
Is this the one that she like gave us time in class but not enough?
It was whatever was on 926.
I think it was like the questions, like the,
Oh, and there was like 9 questions?
yeah, and she gave us a minute.
Maybe that's what it was. Yeah, that way, it was like a minute per question. It was miserable. And she was like, I need 3 to 5 sentences. Okay.
Yeah, that was not good.
Okay.
Who's the teacher?
Later French.
Oh, I don't know who that
I
is.
don't think she's a full-time professor.
Okay,
We weren't really supposed to have this professor.
well, she's probably not paid enough to be fair.
She got 3 weeks to make the class curriculum
Gee, but that like.
or something like that. Whenever that whole thing happened.
Vincent, how do you feel about working this one with me?
Oh, sure.
Cool, help me out, friend. All right, so we're going around x equals -1. Go.
So I think the outer,
Let me get set up here.
okay, yeah.
So does this look all good here, set up?
Yes.
Okay, cool. So,
Wait, talk to you real quick.
yeah,
So it's still, yeah, okay, never mind.
what were you
I
gonna
see.
ask?
But if it's, the limit is still from 0 to 0.
Yes, yes.
Yeah, I see that, yeah.
Cool, cool. All right,
I think here I got x squared, or well, yeah, the x squared, plus x.
yeah, cool. Height's the same, right? So
Yeah.
the height's exactly the same, just the new axis, cool.
And then, x plus 1.
X minus -1, yep, perfect. Yeah, no, that's, you said it, you did the simplification, beautiful, that's it. Cool, now quickly, now take this shape and do it around, around y equals
Some positive number.
yeah, exactly, give me one.
+3.
Okay, I love it. We gotta go a little higher, cause.
17.
17. Cool, let's set that up. Do the volume integral, it's a good number. It is a good number. You can see why having the picture is so important, right? At least it is to me, definitely. Ahmad, you wanna go through this one with me?
Maybe.
Okay, cool, alright, fair enough. Alright, so I'll get you set it up. So,
17 minus x.
minus negative x, yeah.
Yeah.
Yeah, good. And we're gonna square that, that's my outer radius, yep. So that's, let me just write this here. Outer squared, yes sir. And what's my inner radius?
Is it x squared
That is part of it, but,
minus x squared?
slow down, hold on. It's gonna be this right here. So whatever that length is.
Oh,
Does that make sense? Cause that's gonna be on the inside, we wanna take that chunk out.
so it's gonna be 17 minus x?
Beautiful. 17 minus x squared.
X squared.
Yes, sir. Square dx, yeah? Do we got this shit?
I got that.
It's not too bad, is it?
It is not, no, it's not what?
It's not too bad, is it?
No, thank you.
Yeah,
Busted,
I
minus
was gonna
one.
ask about that. I was like,
Minus one, there we go. I walk around all day, a point lesser. Can we do this?
Can we do this?
Yeah, I'm not asking will you do it, you can do it.
Find out.
Will you do it, or will you take a 0? I guess those are your options.
Unlikely I'm taking
So,
0.
I would love to collect this on Friday if I could. I don't think it's gonna take long. You could even set up the integrals right by the problem. You don't need a lot of space. Please do your scratch somewhere else. And if you really just like having, you know, a fresh start, then please redo it on, did I not give you one?
no, can I have an extra one just in case?
Sure. Yeah, absolutely.
So relatable.
You sure you just need one extra?
Yeah, just one.
Okay.
Just in case.
Anybody else want an extra?
Actually, I'll take one.
Love it, sure. And anybody else needs more, I'll bring them for you, I'll hook you up.
Oh, you know you.
Oh, you know, yeah.
So we just-
Friday?
Yeah.
Yeah, can we do this by Friday? I think so. I mean, you could probably do it by 3:15, but not with that attitude. Oh,
Sounds
okay.
more fun to do this at like 12:45 on a Wednesday. In Dr. T's office.
No,
On the Wednesday.
no, Doc, you're gonna find Dr. T to be, very,
It's already Wednesday.
yeah, actually, I can't make my office hours on Friday. So should we make it Monday? But I feel like you can do this,
No,
but,
it's good.
but no, I have a stupid meeting, that's the problem, from 1 to 2. Do you guys, you guys let me know, do you just wanna do this, I don't care. Is the starter class on Monday better?
I don't know.
You're like almost done with it, probably.
Does it need to be right for our timetable?
Yeah, so
or
that's
just
what
completion?
that's a good
Say that
question.
again?
Is it completion or is it like graded based on the right or wrong answer?
It is graded based on right or wrong answers.
What happens if I get a 4 out of 10 on the first attempt?
First attempt, there's attempts.
Is there attempts? Wait, sorry.
No,
I
there's no,
jumped-
there's like, there is an attempt, there's one attempt.
It's one, it's 4 out of 10 or it's 10 out of 10.
Yeah.
Cool.
Oh, yeah.
That's on me, I should have done that. That's on me,
Yeah,
guys.
I mean, and we can, I'll stay here if you wanna work on it
What I
now,
should've
or
done
whatever
was
you
go to
want.
him
Just
on,
shut my mouth.
on
Sorry,
Friday
guys.
night.
I don't think it could hurt to start on it while we're all here together. But if you don't want to, you can go.
Oh, wait, we don't gotta solve the integral?
No!
Never mind. We're good.
Go, please,
No, that's alright.
get out of here, no, leave, I want you to leave.
I'm better. So we probably, no offense, but I mean, it was, love everyone. Dr. T, up top.
I just have a question about,
Yes, sir.
about this one. Why did you
Oh, because there's a pot, when we do the the radius squared minus outer radius squared minus inner radius squared, that formula involves a pi. When we do the tin cans, that's the two pi. Good question.
You got some? Oh.
So let's see if we can get this done by Friday and just see how it goes. You can email me and. Yes, sir. Yeah, okay. Bye.
For this time, should we use,
Yeah, go, man.
should we use, Desmos for this?
Oh, yeah, sure, yeah, definitely. I mean, I kinda think you could probably sketch this all out on your own by,
Okay.
I mean, what's this look like? Yeah, parabola. Y equals 4 is the horizontal line across the top. You'll need to figure out your bounds, so that'll be about it, but you can use Desmos, of course.
Wait, but I thought we weren't solving integrals, so then it's just A
You still
and B.
need the bounds.
A and B bounds, I thought.
Well, you're gonna tell me what A and B are, 'cause notice I didn't put I put 0 and 2 when it was 0 to 2, right?
Oh,
So,
So then I have, then can you use those most of them? You gotta find the balance for calculating.
Jose, can you use Desmos?
Yes.
Well, I didn't, no, I didn't know if that was, I didn't know if that was what you meant. by
Yeah,
this.
yeah.
So we
So-
have to find the intersection point.
You do, oh my goodness, you guys.
Wait, I'll figure it out, don't worry.
Okay, I'm not freaking out.
I was just asking.
No,
I'm assuming it's 2.
That's a good assumption, that man's doing calc in his head, not even calc, right? But
That's your region.
And yes, as our friend Yusuke has given us, that is 2.
Why?
This is y equals x squared, this is 4. When does y equals x squared hit y equal 4? Cool, you cool on that? You cool on that now?
Yeah.
Cool. Hey, let me just ask you something really quick. What if I'd said y equals 9? What would you say for your bounds? If that's y equals x squared. What's that x coordinate right there? I got so much faith in you. I got way more faith in you than you do.
I think that's true, actually.
I know it's true. I know it's true.
Funny you say that.
I'm not even joking.
So, oh yeah, 'cause they canceled it all week.
Yes.
The corrections.
Yeah, I don't have them back yet. I'll have them
Well,
Friday.
okay.
Wait, what? I'm sorry.
I knew you didn't have them back.
I will have them, I have to have them on Thursday, cause midterm grades are due on Thursday.
Tomorrow.
Yeah, tomorrow, AKA tomorrow, yeah.
Oh gosh, it is tomorrow.
What's tomorrow?
Thursday?
Yeah.
I just, I have no clue what day it is. Usually-
Yeah, I barely do, especially with that day
During
off.
the weeks, I just don't know what
You're not gonna be
day it
able, are you gonna be
is.
able?
I have, yeah.
Unless it's Friday.
Yeah.
Oh,
yeah.
If it's Friday, I know.
We have options.
But like if somebody asks me,
Maybe
I'm
I'll
like,
see you.
Thanks, guys. If you see
Okay,
me,
bye.
you're
asking
you
the
can
wrong
shout
guy.
at me.
how
Maybe I should
close
skip
it
school.
during the weeks.
We have 5 weeks, 5 full weeks until Thanksgiving break.
Oh, they're gonna send it to like finals,
No, I wish, but
other than summer.
5 full weeks, then we have Thanksgiving.
Is exam due next Friday?
Before or after?
Is that what it says on the syllabus?
I'm asking based off of my
Good.
analysis. If you don't
Gosh,
know.
No, if it is, it'll just be a take home. If it's next Friday, but I don't,
I heard rumors about Dr. T take homes.
did you?
I did.
What'd you hear about?
I heard
it?
they're
It
hard.
wasn't
You might be-
good.
you might be talking too much. You might be
Close
talking
done.
Yeah, they're,
Let's talk about
I mean, they're a little more, the one I would give you guys wouldn't be the one that I would give in a 400 level class.
It wouldn't?
Would not be, no, I would not brutalize you. I would just like give you a normal exam and say do it at home, cause I don't wanna waste class time on it,
I like that.
That's fair.
right? No. How was that last exam? Did you think that was hard or easy?
Yeah,
Thought that was hard?
unfortunately. I don't know why, well, like the one you took, the one I took here? Yeah. I guess I didn't think it was hard, I think I felt underprepared.
There was that,
Yeah,
but if you have a take home,
can't be underprepared.
can't be,
It's impossible.
you can just be under efforted,
If you can, yeah,
yeah. my god, I have so much to do
It's
for
Wednesday.
tomorrow.
Is that
Oh,
No, I'm having the same problem. I got so much shit.
I so wish it wasn't Thursday.
I so wish I
I'm
was
busy.
more productive on Monday and Tuesday.
I'm busy today. Tomorrow,
There's no math club this week, right?
No,
Okay.
thank God.
That would be really bad.
That would suck.
That would be really bad. I have a birthday. I do it at dinner tonight. And that's
That's nice.
usually not a good, bad thing, but when you're busy it is.
Yeah,
You know what
my
I mean?
favorite plans are the ones that get canceled.
Yes, that's so real. Yeah, that is real. It's not that I don't wanna go out for dinner with my grandparents, okay? But I got shit to do. And
No,
it's-
I mean, maybe you should just ask them if you can do it this weekend.
Well, it's my birthday's tomorrow and
Happy birthday.
They wanna take me for my birthday, but I can't go tomorrow and I definitely don't wanna go on Friday night, so.
With your grandparents.
Yeah, so Wednesday night's the best compromise.
Got it.
And then if it was the weekend, then it's like not even my birthday anymore, so it doesn't
Are
count.
they gonna take you out for a long, like 3-hour dinner?
Probably, dude. We're going to the Thirsty Lion on Grand Central Station,
Mm.
so it's probably not gonna be a short thing,
Yeah.
but hopefully not like a 5 or. And of course, she has to buy me dessert every time, even it's like, guys.
I never want
you
to stay.
sound privileged.
It's like, guys.
Yeah.
I know, I do sound so privileged. It's
These
the
are
worst. It's
first
like,
world problems.
I'm complaining,
Yeah.
I'm complaining about these things, and I totally know that it's like completely irrelevant to what I'm complaining about, but I feel like these are, we all live privileged lives, if that's
Oh,
the case,
100%.
right?
Yeah.
So,
And I still bitch about all sorts of
first world
things.
problems.
First world problems.
Yeah.
Alright.
I might get going.
Yeah.
That would.
Sounds
Fine.
good. You guys, thanks. You don't have, I just harass you, and I shouldn't harass you, because I think you take it to heart.
Not or not.
Okay, good.
It's just things.
It's just wackiness. Oh, fuck. God, getting those grades in tomorrow. Oh. But I can tell you what, I'm gonna be kind.
Thank you.
It doesn't matter, no,
Yeah,
you can be,
everybody
honestly,
can be
you can be so mean, because it's the midterm.
Well, I am a little, probably I'm worried about someone,
Well-
but I'm not worried about any of you, so.
That's good.
You need someone in class.
And in general.
Besides,
You're dropping lore right now, you need to worry about that.
Dropping lore, I was like, there's a lore in this class? Well, these definitely failed. Bye, thanks guys.
I don't even know what a lore is.
A man named Lore.
Like you're like, I don't know who
I
that
don't
is.
know, Lore is flunking out.
Like lore, like lore.
like teeth.
By with an E. Yes.
Lore with,
you're-
yeah, lore with an E, yeah,
Bye.
alright.
Yeah.
Your iPad's still here.
I'll still see you guys.
Oh yeah, don't forget your iPad.